Okay, let's get started. So last class, we started talking about return-oriented programming. We saw one example in which we use ROP to set the function parameters. Hopefully now you can see why the title of the original paper was the geometry of innocent flesh on the bone. So here, the innocent flesh means those bytes who were generated by legit instructions. However, if we reassemble them, they can be reassembled to the instructions attackers want. So they were originally innocent, but we can chain the innocent bytes together to do something malicious. So the ROP is kind of like you break down Lego pieces, for example, your Lego Yoda, and reuse the pieces and build a Darth Vader out of them, kind of like that, right? Today, we are going to say another example to capture the flag using the ROP technique. Next class, we're going to say another more complicated example, which actually was one gadget. So before we dive into that example, let's say some useful gadgets you may use when you build a ROP chain. For example, if you want to skip some data on the stack, you can just pop them into registers you don't want to use. For example, if you want to skip two items, then you just pop twice. 3 items, just pop 3 times. This is useful, as you can see. Last class, we couldn't find the gadgets we want, but we can reuse other gadgets and put some garbage on the stack and to make them semantically equivalent. Also, similar to the NOP-SLED in our shellcode, you can also have some kind of a LOP for ROP chains. So basically, you look for gadgets like just one return. So that will not do anything, but just keep moving the RSP or ESP up. So that's kind of like a NOP. You don't have to specifically look for something like a NOP return, which is difficult to find anyway, right? Also, here is a very interesting gadget. So in ROP, the attacker still need to control the stack. But what if our ability to control the stack is limited? For example, we can only overwrite 20 bytes on the stack, but we need much more space there. So how do we do that? So there are some gadgets you can change your stack pointer. You can change the RSP or ESP. So you can make the RSP ESP to point to another location. And in that, maybe at that another location, you don't have the constraint of 20 bytes anymore. For example, you can make the RSP PSP points to a environmental variable, which you can control, and you can have as many bytes as you want it. So in that case, there are several gadgets people find in the wild. For example, one of them is exchange RAX RSP return. So in this gadget, as long as you can set RAX to whatever you want, so basically you should look for another, like maybe something like a pop RAX return gadgets to set RAX. Then you can exchange RAX to RSP. Basically, you are setting RSP. Then you can change RSP to whatever you want. Also, if you can find gadgets like pop RSP, you can also do that, but sometimes you cannot find those gadgets. Some gadgets are difficult to find anyway. Another thing is you do not really find many gadgets have a syscall. For example, you don't really find like a syscall return. That will be a gadget, but that was very difficult to find. First of all, syscall is I don't know how many bytes, so it doesn't happen randomly in the memory very often. Second, real world programs will not have a syscall return. Usually do not have something like that. It's like you just make a system call, then your function return. So it doesn't happen that way. So to do that, so to make system calls, we need to think about other approach. So today we're going to say, how do we handle this? So this is basically, so the tool we're using, RobGadgets, it can automatically generate something called a Rob chain share-code. But this is not going to work in our class because in our server doesn't allow you to create a new process. But you can use this approach, use this command to generate a share code and take a look to understand how it achieves that. Okay, so today what we are going to do is we are going to open the flag file and print it out to get the flag. The target program will be the 64-bit version overflow return 4, no cookie. So you have been hacking. So this program, the stack is not executable. You have been hacking other versions of overflow return 4, but not this version. So this version, there's no cookie. You can overwrite the stack, but the stack is not executable. The program is dynamically linked, so it doesn't have as many gadgets as you want. So but this is not a problem, right? So they were load libc anyway, so you can look for gadgets in libc. So how do we approach this? Let's first think about how we read a file and print it out. So here I have the share code to remind you how it works. So basically what we need to do is we need to make at least 2 system calls. One is open system call, another one is a send file system call. In the 32-bit version and a 64-bit version, you did both of them, right? So what you did was you set up registers, and in 32-bit, you just use int 80 as a system call instruction. You use it twice. Actually, the template I gave you guys, we did it 3 times. We have an exit at the end as well. But technically, that exit only makes your program to exit gracefully if something goes wrong. So it's not really required. In the 64-bit version, instead of using the int 80, the instruction, you were just using the instruction syscall. Okay, that is an instruction available at the 64-bit version. So if we follow this approach, if we want to directly map that regular share code to this Rob chain share code, this is what the stack we wanted to look like, right? So this is a vulnerable buffer. This is a saved RBP, and the first item here is used to be the return address. So we're going to overwrite it, right? So we first want to have some gadgets set up here to have the first open system call, right? We set up the RDI, RSI, those those registers here. So the on the stack we will have the address of those gadgets. Then we will have the address of a gadget, syscall, and return. Okay, the problem is here. You cannot really find a gadget like this. Okay, with libc you can not, it doesn't exist. Okay, so let's pretend this works. Then what we do next is we put more address of other gadgets there to set up the parameters for send file, right? Then we just do a lot of syscall. Remember this time, the second time you don't need a return at the end. The first time you do need a return because you want to give the control to here. This time you don't have to. Without that return, your system may crash, but that time you already get the flag, so it doesn't really matter. So this part we can still use the syscall, but the first part we have to get a gadget like syscall or return, which doesn't exist. So we need to find a way to bypass that. To show you this is a real problem, let's just do a let's just try to search for those gadgets. Let's see if they exist. Let me just copy this one. No, we don't need this. We don't need this. Copy this command here. Okay, so let's do LDD. Let's do the battery. Let's search for libc first because it's big. libc. Ooh, I have so many here. Yeah, let's do the sixth version. So let's do a grep syscall, right? Let's see if we can find any. See, all the syscall we find, it will be at the end. There is no return after syscall. So we can only use this as our last syscall, cannot use them as the first or the ones in the middle. See, all of them. Doesn't exist a syscall return thing there. Any questions so far? I cannot really see the chat box. So if you have questions, just ask, okay? Oops. Okay, no question there. Yeah, we could not find any of those. So any idea how do we bypass this? How can we make systems calls without actually using the syscall instruction? How do we do that? Any idea? Okay, show me something. So I know you guys are still here. Okay, so Edmond say syscall wrapper in libc. Yeah, yeah, that's exactly what we are going to do. So we're not going to directly make system calls using the syscall instruction. Instead, we call libc functions. And we know that most of system calls, well, most of them have a corresponding C wrapper. So we are going to call those functions. Let's say, for example, we are going to change the stack, look like this. We are going to still we overwrite buffer, we overwrite RBP, we have gadgets to set up the registers. But now when we set up the registers, we do not follow the system calls convention anymore. We follow the functions calls convention because we are going to call the function. We're not making system call directly. Then after that, we get the address of the corresponding say library function, for example, open 64. So open, it's 64-bit version is called open 64. Then we can do a send file 64. Well, this one, like I said, this one you don't have to call a function. You actually can use a system call, but we can do both of them to functions. Okay, so let's say how do we do that? So today we are going to, today I'm going to give you the idea how to do that. I will give you a template. So you will work on that by yourself, okay? Because I see there is a problem the way I'm teaching the class now. For a lot of the homework, I ask you guys to replicate what I did in class. My idea was to, by replicating what I did in class, you should be fully understand, you will be fully, you will fully understand what's going on, right? However, I realized that many of you were copy what I did in the class just byte by byte. So you do get the flag, you do get a full mark in the homework, but what you didn't really understand what's going on. So when we go to the midterm, many of you couldn't solve those challenges. So today I'm changing this a little bit. I'm giving you the template. I'm telling you what's going on, but I'm not going to show you the demo. You need to do everything by yourself, okay? So this here we have the vulnerable function. This is the one you hacked before with a different approach when the stack was executable. So we have a vol-foo, there's a buffer 30 bytes at C level. We have a gets, which is the vulnerability here. So using gets, we will be able to put whatever onto the stack, even our shellcode. But if we put shellcode there, it will not be executable. So that approach will not be working. What we are going to do is we're going to use gets to overwrite the stack with the rob chain, not the shellcode. So this is a template I will give you guys, and you need to make this work. So on left hand side, I have the script similar to the previous one. This is Python 2. Use the struct pack. So you need to find the 3 addresses by yourself. One is the address of send file, which is a function, send file 64. This is a function. You need to find the address of open. You need to find where the data section is, because we're going to use it, okay? So for this one, if we do a simple disassembly, let's do a simple disassembly here. Let's do the 64-bit version. We do it simple. So you can say the vol-foo is here. The buffer is actually at RBP minus 30 in hex. 30 in hex, that's 48 bytes, right? That's why that 48 bytes plus the saved RBP would be 56 bytes. That's why at the beginning, I have 56 bytes of padding at the beginning. Then after that, this is our rob chain. Let me explain this to you one by one. First, I have so this is what we're going to do. We are going to first call the function open. So since we are making function call, the first parameter will be flag, right? The string flag, not secret. You can do // flag, whatever. That address of that string, the flag string, has to be stored in RDI. Then the second parameter doesn't matter. You can just set it as 0 to RSI. So the return value of this will be in where? This is a function call. So the return will be in RAX, right? 32-bit, the function call return value will be in RAX. 64-bit, the return value will be in RAX. Then we're going to make the second function call, which is send file. or 65 or 64. So the first argument will be 1 because we're outputting to std out, which has a file descriptor number 1. So SDI should be set as 1. So RSI will have the return value from RAX, right? So we need to move RAX to RSI. Then the third argument, I don't remember what that is, but we can just set it as 0. The fourth one, RCX, is actually how many bytes you want to write. So let's just do 1000. The number doesn't really matter. I mean, because our flag file is not that big. If you do 50, that will work. So this is how we are going to construct our chain. Let's take a look. First, mainly look at the comment part, okay? Because the comment part is what we are actually doing. Before that is just the address for the gadgets you need to fill in, and also sometimes you need to fill in some data. So let's see what we're doing. We pop RDI, which means the next address we are going to move to RDI, okay? So what is the next address? The next address is the address of the data section. We're moving that to RDI, okay? Then we're popping RAX, and here we're popping the string. Okay, so it looks a little bit weird. We're not directly putting the string's address. Well, we do put a string this on the stack, right? By doing this, we are putting a string on the stack, see? Because the whole thing will go to stack. But when we do that, we cannot get the address. We do not find the gadgets to do that. That's why we are taking a weird approach here. First, we get the address of .data. .data is a region we can write. We know that we can safely write that region. Okay, so RDI here is actually the destination we're going to write. Then we move the string itself. Note that's a string itself to RAX. Okay, then after that we have another gadget to move RAX to the memory where RDI points to. RDI points to the data region. RAX has a string. So we are writing that string to that data section. So now we have that string in the data section, and we know where it is. It is in RDI, right? So RDI points to that string now. So after that, we need to set RSI. So what we did is we just set RDI to make it points to the flag, whatever, the file name. Then we have RSI, which is a 0. Okay, this one is easy. We just do pop RSI return, and the next item we just set as 0. That's it. So after that, we just make the system call to open 64, and that's easy. We just need to get the address of open, which is this one. So after that, what do we get? We get the file descriptor of the opened file in RAX, and we need to move that to RSI. So how do we do that? We directly, well, the either way is we directly look for the gadgets, like maybe there is a gadgets like a move RSI RAX. Okay, we directly look for those gadgets, and actually we find one. So this is what the share code I wrote before. I could find a gadgets like this, okay? But I cannot directly find a move RSI RAX return. No, I couldn't find that. Instead, I find a long gadget like this. Move RSI RAX, right shift ECX 3-bit, or 3 times, then repeat move those 2 things, then return. You can see that I don't really care those things, okay? What I only care is this one, but those instructions will be executed. So I need to say if there are some side effects that may crash my program. So it looks like that what those instructions are doing is to doing some memory move from the RSI points to the memory to the RDI pointed to memory, and we are going to move to the times we are going to move is depends on ECX. So as long as ECX at the beginning of the program is 0, then those two instructions are not going to do anything. Okay, I think we will be usually will be lucky here. It will be 0. Or if it's not 0, let's say, if it's not 0, it may get a system crash. It will get a segment fault. It's possible. So when you run this, you may find this is not working on your container. You may need to set ECX somehow, or you may look for a lot of gadgets. Okay, but be creative. But anyway, this one works for me before. Then after that, we set RSI of the second system call. Then we still need to set RDI, RDX, RCX. And those are easy. RDI, there is a RDI return gadgets. RDX, I could find a pop RDX, pop R2 gadgets. That's why I put 2 things here. The second one maps to R12, which we don't care the value. Then we can find the pop RCX. Oh, here I'm using 80. I'm not using 1000. You can see that, right? Then after that, just the address of send file. So after send file, technically we're done, right? We're done. We already get the flag. But if you want to quit, gracefully, you make another exit system call. And this is the last one. We don't need to return. That's why we can make a system call. You use the system call instruction directly and set the RAX as 60. That's the system call number of exit at 64-bit machine. And here we're popping RAX. We're not using the return value of send file. We don't care, right? Does that make sense?
Professor, can you once again explain this data part alone?
Okay, the reason we have data part is we have a string, right? The string will be the file name. That file name, we needed to get its address in the memory space because we are going to set RDI as the address of that string, right? We're not setting RDI as the string itself. We're setting RDI as the address of that string. So to do that, we need to put the address to somewhere we know. For example, here, we actually, by doing this, we're copying the string to a stack. But can we get the address of it? If we can, the address of it.
String. This is not an instruction, right? It's just going to be a string.
Yeah, that's a string. This is a file name. That's a file name. The file you want to open. Not an instruction. Nothing here is instruction. None of the items is instruction. There can only be address, data, cannot be instruction because you're not going to execute here.
Oh, okay, I get it now. So if you put secret on the stack, once once this instruction of pop RAX gets executed, we'll be stack will be pointing to the secret, and then RAX will be stored to secret. Am I correct here?
Well, when you do this, so basically this is what the stack look like, right? So here, when you do pop RAX return, the value, the string will be popped into RAX. Okay, not the address, the string. But we're going to save the string to a data location. We know where it is. We're going to save it to the .data section in the memory. And we know where it is. So we can get the address.
Okay, I get it.
Here, let's say, we do have the string here. But how do you know the address of this? How do you get the address? You see the point here?
Anyways, if pop happens, the stack is going to point to the next address on top of it, right?
Yes, so that address will be, at some point, it will be in RSP, right? But you need to find So you need to move that RSP to RDI. As long as you can do that, it's okay. But maybe we cannot find the gadgets to do that. Let's try. Let's say we can use a command we used before. For library, should I go for directly copy this whole thing? Okay, so let's say at some point RSP points to that. So let's maybe find our gadgets, move RSP or move anything to RSP, right? Move RSP to anything. The problem is you will never find the gadgets like that. Let's say. So here you say those gadgets are moving. Which
We have one,
direction?
right? Move RSP, RDX, and return.
Yes. Hold on. Let's say. Which direction is this? This one is move this one to this one, right? Which syntax is this? This is the Intel.
And it's moving RDX to RSP.
It's moving this one to here. Oh yeah, it's moving RDX to RSP, right? Okay. So what we need is we're moving anything to from RSP to anything, the reversed order, right? So how do I write the regular expression here? So I can't do anything. Is this how do I do it? Don't remember. Then I do RSP. This one. No. Hold on. Let me get this tool first. This tool can also have its own syntax here. Let's see. So there is only. Oh, this is only instruction. This one filter only also filter instruction. So, okay, can someone help me here? So how should I write the a regular expression to make it? I haven't been writing regular expression for a long time. Should I use star or, for example, I want to be anything star. How do I do that?
What if you filtered only move and then grep RSP?
Okay, that makes sense too. So what you want to do is we do only move return. Then after this we grep RSP, but this will also give us no, the syntax is hold on. This will not give us all possible ones because if there are 3 moves, will still work, right? Anyway, so you can see this one we still cannot find the gadgets we want. We're still moving something to RSP where we're not moving RSP to anywhere, right? So basically I'm saying this is not the approach I'm showing you is not the only approach. If you can find some smart gadgets, okay, you are smart enough to function gadgets to set RDI, then you can go for that approach as well, okay? But do you understand how this one works? Why do we do data? For example, we don't have to do dot data section. The reason we do dot data section is we know that section is writable. We're not going to get any segment fault.
Professor?
There are other memory locations we can also write to and do not get a segment for. We can also choose those. Yeah.
Could we do something like we had to do in the midterm, where you put the string in an environment variable? Would that work here?
That will work. But a little bit tricky is, no, that one actually will not be very difficult. You can do that. You put the environment variable, you put the string in the environment variable, and that string can be very, very long, right? So here's the approach I'm using. There is a limit. The string actually should be 8 bytes, right? Which means I do not, well, in this case, I don't really need any padding as well, actually. But the approach you are saying is we can get a lot of slashes there, a lot of slashes, then flag, then get the relative, to get the address of that string, then we directly, so we don't need those, we don't need, let's say, all of this, we don't need that. From here to here, those 3 items, those 4 items, this one, this one, this one, this one, we will not need those, okay? We only needed the address of RDI. Then here we have that address of the string, which you can get from get environment. Yeah, that works. That will make it easier. Okay, any other questions? Seems there are. Okay, if there are no other questions, then you guys can start working on this now. Maybe some of you can share the screen and show us, maybe just one of you can share the screen and show us what you are trying to do, okay? So I can help you there. So don't be shy. Who wants to do that? By the way, I already post all the slides on my website, so you can get the template. I don't know who asked that question just now, but that's a good way to make this a little bit simpler. Okay, any of you wants to share the screen? Don't be shy, it will be fun. So how do you plan to get the address of those 2 functions?
We can use num and find those functions.
You can use what? I didn't hear you.
num function, an num tool, or GDB to find the runtime address.
Okay, yeah, you can use GDB. You can just do p that function name, then you can find it. Yeah. Okay, I think you can start working on this. It's simple in theory, but when you do it, you realize there may be a lot of issues. Anyone wants to share screen? If no one wants to share, I'm going to call out someone. Oh, when I said I'm going to call out someone, someone just quit.
I'll share my screen, Professor.
Oh, I was about to call you. Do you know that?
Oh, okay.
Anyway, go ahead.
Okay.
Well, what a coincidence.
Oh, I need a co-host.
Of course. Go ahead. I swear I was about to call you. Thank you, Andrew, for sharing.
Mhm. Okay. Yeah, I'm just trying to follow the template from the notes.
Mm-hmm.
Oh wait, I should probably put the string in an environment variable first, right?
Yeah, you can do that. It can be anything. I mean, that doesn't matter, right?
So this would work.
I would maybe suggest you give a longer, more snatches there. Yeah, just more snatch. Yeah, that will work actually. Yeah.
Okay.
Looks good. I would suggest you to copy the whole thing to the server first, then change what you want to do there. Basically, change the common part, delete the part you don't want, delete the lines you
Okay.
don't need. Yeah.
Will these addresses be the same?
No, no.
Okay, that's
You
what
need
I
to
thought.
find them out. Yeah. So you are a Emacs user.
Mm-hmm.
You know how to select. So let's say what you want to do here. You do not need those pop anymore.
Wait, I still need this first one, right?
Yeah, you still need the first one. Yes.
But then these aren't. I don't need these three.
Let's say those technically 4 lines, right? Those 4. Yeah, I think that's those 4 you don't need. Yeah.
Okay.
But you will need a new line there.
So now, um, I'll do this, right?
Yeah, you probably want to add something to that address.
Oh yeah.
Yeah, maybe 7, 8, say I would say. Yeah.
Wait, 7, 8, C?
Maybe 7, say. Maybe in 7,
Okay.
say instead of 5, say. Yeah.
Okay. So,
Later, if it doesn't work, then we can debug to see if that address is good.
okay. So, but I have to update all the, like, this first line, I have to update this, correct?
Yes, you need to update all those addresses.
Okay.
That's why you can use Tmux there.
Mm,
You can use Tmux here to have two windows to help you. That'll be easier. You can do, yeah. One you have Emacs, the other one you just check the address.
is there a way to get rid of this?
No easy way. I don't know. I mean,
All right. Because this one, I don't remember which homework it was, but I used Tmux in the same way, and it was annoying. So now I have to load the program.
Yeah.
And oh, I see. This is my offset, correct?
Exactly. That's your offset. Yeah. Then you can look for the gadgets. So you mistyped there. You mistyped two places actually. Yeah.
This should be that.
Yeah. You needed that white space because this
Oh, okay.
because we're doing a grep here. Yeah.
Oh, because it would look for that as RDI semicolon as one thing.
Exactly. Otherwise, I mean, if you use a regular expression, I mean, you can find better ways. Yeah. So now you find the address. See, that's they are different, right? They are different because I think because every container. Oh, for every container, it may be the same actually, because it depends on when we disable the ASLR. After we disable ASLR, then everything may be the same address. Yeah. Okay. I think you can try if it works. If after you set open, then you can say if it worked by debug it to say if the open will be successful.
Oh yeah, I have to find the address of open now, right?
Yes.
Okay.
Open is not here. That's not a gadget.
Oh,
Gadgets are instructions.
gotcha.
You're looking for the address of that function actually here.
Would I have to do it in like the way that we did earlier in the semester where we just looked through the C functions and we found like /bin sh? Like I don't remember how we did it, but would it be like that?
No. This is a function, not a name. Okay. So for example, you do GDB. Let's do GDB. That program. Okay. Go there. Then set a breakpoint at the main function. Let's say. Okay. Then you run. Just do R. Okay. Now the whole thing is loaded. Everything is loaded, including libc. So you do a print that, yeah. Then you get the address of that function.
Oh, okay. So this is just the address then that I need.
Exactly, because this is where you want to jump to or return to. Yeah. There are other approaches to get this as well. We can try that. Let's say, yeah, finish that first. Then,
okay.
You can do a maybe you can do a nm on the libc. Then you should supposed to get the offset of that function.
And
The whole C library.
then do I have to grep for?
Exactly. Yeah. You need the C library's name, same as when you do the name you get from LDD.
Oh, okay.
Yeah.
So do I need the offset then, or just like this part?
Technically, you will need the offset, but we can try this. Yeah.
Okay.
First.
Okay. So.
Then you do a grep open 64. No symbol. We do not find it.
So.
Hold on. Why there's no symbol? It's not the grep. It's
an NM issue.
Yeah. There's no symbol. This is stripped. That makes sense. Can I do without the grep? No symbol. How come there's no symbol? Can I do a file on this one?
What file? This.
Yeah. Oh.
Is this what I need then?
Yeah. Let's use that one. Yeah. That's When we do nm, it's actually interesting. So that it's not there. It's in the library folder.
Oh, it's just /lib/
Yeah,
this.
let's try that. Yeah, it should be stab lib, then there will be for different architectures, I believe. Yeah. Okay, we don't have to work on this one. Okay. Let's
I can
maybe
just run this.
Yeah, generate some exploits, and let's debug this to see if your approach works first. Your open approach works.
Okay, so just save this and exit. And now
you don't have the exploit yet.
Oh, is that not the exploit?
No, that's a Python code, right? Your exploit is actually binary. The binary you are going to overwrite to the stack. So the Python script is to generate the exploit.
So I'm just gonna like print that to a file.
You need to run that Python. You need to run that Python code. Okay, you need to say permission denied. You need to not because of that, because it's not executable. You didn't give it executable permission. You need to change mode.
Oh yeah. Plus X, right?
Yeah, CH, not CD. Yeah.
Oh.
Okay, now you can execute it. Okay, there is syntax error somewhere. Let's see. Oh,
it's line 18.
That's just and comment there. Yeah, make a comment.
Okay.
Okay, so this exploit, you know that it's not going to fully work, but before open, the open should work, right? So back to say if it works. Yeah.
So now, do I have to put this into a file?
You don't have to. Well, you can. Yeah, you can put it in a file to make sense easier.
So I would do like this and then redirect to like.
Yeah.
And, and temp. To redirect it, it's just the same as regular, right?
Yes. Yep.
Okay.
Then we have a valve, right? Yeah.
Oh, should I set a breakpoint at Volfu?
Yeah. Well, technically, we should set a breakpoint at the end of valve. Yeah, but you can get there first. Then we keep saying.
Okay.
Okay.
So here, right?
Exactly. That's where we want to go. Yeah. Okay. So now when we return, you should return to RDI, right? I think it's RDI. So if you do SI, you should go to, let's say where we get. Okay, we can do you can do a X. So how do you know what you are executing here?
You do X by X, right? And then this address. Or could I just search?
You can just use RIP, right? No. You still do you don't need to copy that address. That address is already in RIP. You need a $sign first.
Yeah.
Okay. Okay. So what's wrong with this?
So it's.
So what you are trying to do is to interpret that as instructions. So that's why you should do the second X. You should not use X. You should use I.
Oh.
That will be instruction. And you want to say many instructions, right? So maybe you want to do 10 instructions.
10, right?
Okay.
Okay.
Okay. That look like the copy was successful. What's wrong?
So is this returned it to just some random place inside the C library? Is that what happened?
No. Look at this address.
Mm-hmm.
That address is correct, right?
Yeah.
The address is actually correct. That is the address you put in your code.
Mm-hmm.
But somehow when you get there, you do not get the gadget.
Okay.
That address is supposed to have the gadget, but somehow you don't have that.
Is it like the environment variable where it's like not perfectly accurate?
No. We're not there yet. We're not talking about the string yet.
No, I mean like on the midterm.
Yes. Yeah.
It was like off by a little bit. The address that when you used get environment.
Not because of that. Because here you are supposed to get to the gadgets pop RDI. That has nothing to do with the environment variable. I think it's probably we copied the wrong address. So what do we have here? Let's say 7DECB72. Okay, can we get it out and check the address again? Can you do that grep again? Is that yeah, RDI, right?
I believe so.
Yeah. So also no the offset.
Oh, okay.
So maybe let's see what's wrong. Let's see. Oh, it looks correct.
DECB72 TEC. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72. 72
Is that offset correct? Can I do a LDD again?
It's the same offset.
Okay, the offset is also, that offset is correct. The gadgets you get is correct. But somehow we go there, we didn't get the gadgets. We don't find the gadgets. We get zeros. Let's see what's going on. Let me take a look. So it's probably the copy was not successful. Why the copy was not successful? We're using gets. So not supposed.
Mm.
Okay, any idea what's going on, guys? Why we do not find the gadgets? Can we debug again?
Mm. Oh, I forgot to the breakpoint.
Can we print out the value in that exploit, temp/e?
What do you mean print out the value?
Print out the content. Because I don't know if that temp/e have the correct exploit, right? Can we get out GDB then?
Should I just cat?
Yeah, just cat or do XXD, maybe better.
Oh, yeah.
Okay, so we have here is that. Does that look correct?
Not really sure. I mean, the A's, it definitely has all the A's, but then this would be where it would start, correct?
Yeah, that looks correct. Then we have the address. There are several things wrong. First of all, the get environment variable, you were using a 32-bit version. You should use 64. But that is not the problem. Okay, I just happen to remember that's an error, but that's not lead to this problem. Yeah.
Okay, so that's first part that's wrong.
Yeah.
Okay.
You still need to add something there.
Oh, yeah, I forgot. Like 80 work?
Yeah, maybe.
Okay. Okay.
Then we go back to debug again.
I need to redo the file.
Yes.
Should I do cat or I just run it, right? And then just
You
redirect
just run that. That's a Python code. Yeah, just run it. Okay. So here, let's examine the stack first.
Okay.
You do a x slash maybe 10 gx. 10 means 10 items. Gx means each item is 8 bytes. G means 8 bytes. X means we're showing hex.
Okay, so then
Just RSP. Okay, so let's say that's correct, right? The first
Yeah,
one
so
is gadgets. The second
yeah.
one is
the
okay.
address.
Okay,
Okay.
so we
That's
just do SI.
So
Okay.
now, what was it? X by I,
Yep.
RIP.
Yes.
It's the same thing as before.
That's weird. Why we're not? Because we're here. Why this is 0? Because that and thing is just 0.
Hmm.
But we know this one is not 0. Something.
Yeah, it's the same exact thing as before.
Yeah. What's
Can I
going
do
on here?
this work? Could I do that?
No, because you are going to execute at that address, CB78, right?
Mm-hmm.
That's where you're going to but somehow you are not. That's really weird. I've never seen this before. Let me think what's wrong here. We verified that address. Well, maybe let's look for another gadget.
Okay.
Yeah, I don't know why the C library is not loaded there. Oh, okay. Anyway, can you use that RobGadget? I think we can find the gadgets in that RobGadget command to find the gadgets instead of let's say how we did it before. Let's say binary, this library, this offset. Everything looks good. How about let's just find the gadgets in the program itself instead of in the C library.
So instead of doing C library, then I would just do like
Yes.
the program.
Yeah, just do the program. Let's say we can find a gadget like that. Okay, we find one.
But this is just an offset, correct?
This looks like an offset. Yes.
So could I get the correct one by adding like the could I add that 1223 to the
No.
offset?
No,
No?
because we don't know the base. Because the LDD doesn't tell us its own module where it will be loaded. Okay, let's do it. Can you do a LDD again? Yeah, do this again. Are they the same? The output?
Yes.
They are the same, right?
Same offsets and everything.
They are the same. So we don't have ASLR. I was afraid that ASLR is on. It's not the case. Why the gadgets are not there? We find it there, but why it's not there? Anyone said offset not working. What do you mean?
If I try the address for Open64.
It's a looker. Okay. But why this is happening? We didn't change the server anyhow, but Monday it works. When I show you guys the demo, it works, right? I'm trying to think what's going on here. Why it's not working anymore?
what if I just reload the?
Then did you make a backup? You didn't.
No.
Yeah, you have to
I mean,
regret. Yeah.
I basically didn't make any progress then because
Hold
nothing.
on. This is 32-bit.
Aha.
We're doing. Did so we were working on 32-bit? No, I don't think so, right?
I'm pretty sure I had the 32-bit one open while you were still doing lecture.
Oh.
So we were debugging because we were in the wrong challenge.
Oh, really?
I think so.
Oh, interesting. But when we do LDD, everything it was looks like 64-bit.
I'm not sure.
Okay. Yeah, it was 64-bit, I believe. Yeah. Okay, what's going on here? Okay, I'm not sure what's going on. I will also debug a little bit to say later.
Okay.
Yeah, this is a weird case.
These are the same numbers from before.
It should be, yeah, because we didn't enable ASR. They should be the same. I just don't know why at that address we do not have the gadget.
Could we? I could just try like the ROP command, and then like Edwin said that it wasn't Open64 was wrong.
No, we're not there yet. We couldn't find even the first gadget. See, we're not. So element.
That's what I mean, like just as a test.
That's weird because it worked Monday. Monday we were able to find the gadgets. We debugged. It works. Why it's not working now?
Yeah, this is also the same address as before.
Yeah, that's the same address.
Okay.
Can we just debug without just copy that address, then we debug the program? Let's say what that address, what we have, yeah. Yeah, then we just run, then let's just examine what do we get from that address.
Oh, just like
Just to X, exactly, yeah, do that.
do I need the star?
I think so, yeah.
Oh,
No,
oh, so it's
but it has 0, yeah, it has 0. The gadgets is not there. You don't need a star.
oh, okay.
You don't need a star. Yeah, star is like the reference. See, the gadgets is not there.
Yeah, so then if we do it,
Can you do a file? Can you do a file on this program?
could I do it? I take exit GDB, right?
No, just the file. On the no outside of GDB.
Okay.
Just do a file on this our target program. Yeah. Let's see. This is dynamically linked. Everything looks correct. Everything looks correct. That's weird. Let me check. I think it's probably when I compile it, something gets wrong. Let's see. Returns 3. Returns 3 or return 4, this one is.
Return 4.
Return 4. I do not say anything wrong here. That's a bit weird. Okay, I guess I will debug after the class to figure out what's going on. Well, the problem I can say is the gadgets are not there. Looks like the C library is not loaded there. LDD is telling us C library will be loaded there, but seems like it's not. Can you do one more thing for me? It's in GDB. Let's go to GDB again. Set the breakpoint and main or valve doesn't really matter. We run this. Then let's do info spacebar files. Let's do files. Yeah. Let's see where C library is. Just enter. Keep doing that. So we should be able to find.
Is it at the bottom? This one?
Yes, something like that. So you can see there are C library. They are loaded to different locations, right? Different segments load to different sections. So we are looking for TXT section of the C library, basically. Maybe enter again, we will be able to see it. I do not say TXT.
Oh, is it this?
Oh yeah, yeah. See, that's a different address.
Yeah.
That's DF. Which one is the address for new?
That was one we had.
Well, that is the address of that gadgets, right? But not necessarily the address of the base. I'm not sure which one is considered the base.
Could we got that offset earlier? Could we add it to the lowest address for this or no?
Maybe not add to that. Maybe add to the first libc SO. You know, the first section from libc SO. Yeah. Can you scroll up a little bit? Find the first one. See, it's there. I saw that. So see, looks like the first section was loaded to CB350.
Oh, right here.
Yeah.
So then you could use this address as the base?
Maybe.
Really small.
Yeah, maybe that should be the base. I'm not sure which one is the base.
Even both of these, it's a really small.
Yeah, those are very small segment. So probably those should not be the base. Very weird case. So the base I get is DC 6000. The base you get there DC 6000. Oh, those are not sorted, are they? Not sure. Okay, anyway, the class is over. I will try to debug tonight to figure out what's going on.
Okay.
Okay, thank you, Andrew, for sharing today.
Thank you.
I'm sorry that we couldn't get it work, but we will get it later.
Thank you. Have a good night.
Okay, thank you. Bye, everyone. How was the library address printed out in GDB? You do info files.